Hello, Tungsten Miner here. Last time we had talked a bit about some more of the handheld tools, the mining drill and the chemical thrower, along with the bottling plant to fill them up, and a bunch about the various kinds of lighting systems that immersive engineering adds. So let's carry on, and maybe we might get through all the rest of this. Next up is the item router. If you've used Buildcraft before, this is going to be very familiar. It basically works like a diamond pipe from Buildcraft. But in case not, you make one of these things. Pretty simple recipe. The recipe is iron mechanical component, which is just the copper with iron around some treated wood and some iron ingots. And that gets you one of these guys. Right-clicking on it, you can see each of the different sides is assigned a color. So black is, I think this bottom is black, white is top, red is north, west, south, east. And you can see the colors on the side are the same as what they say there. So white on the top is this guy, and you can just take it for granted that the black is on the bottom side. I have placed pieces of wood on these various sides, which lead off to these different chests here. So if I grab all these chunks of wood and just toss them onto the conveyor belts here, you can see that they get shunted off to the sides as configured in the item router. So this thing basically is a diamond pipe for conveyor belts. Because of course the conveyor belts are all going to go into the various sides and it will drop things out the bottom. Very handy if you're working with some of the bigger machines and you need to do a little bit of complicated routing to send things one direction or another to be able to drop into the right slots in the machine. So that's the item router. Next up is the metal press. So here it is in its pre-constructed state. Heavy engineering block, pistons, steel scaffolding, and a little bit of conveyor belts. I'm going to right-click on the piston this time, and that turns it into its multi-block shape. In order for this thing to work, it needs power, so I've provided some, and it needs these molds. So you can make different kinds of things depending upon which mold you have. So if I right-click underneath here with that plate, it's going to put a plate mold, and then I can come over here and drop a piece of iron, which is going to make its way onto the conveyor belt here. Oops, I need to fix my power situation. Connectors, drop those on there, and drop that there. Off it goes. Stamp, and now I've got an iron plate. If I came along and right-click with this guy, it's going to replace the plates with that one, and I can drop that guy over there, and he's going to go through and stamp and wind up as an iron rod. And then finally, if I switch the plates again and drop this guy, we're going to wind up with an iron gear. Now you notice it's hanging out here. So actually an iron gear requires more than one iron ingot. So there's 2, 3, 4, and 5. And now it's going to go ahead and get stamped. Must have grabbed an extra. So yeah, different stamps require different amounts of material. If I want to just take the stamp off, I can shift right click with an empty hand, and it's going to grab that mold off again. And that's it for the stamping machine. This is the nascent form of a crusher. So if I come along and assemble this guy, you can see steel scaffolding underneath for the most part. I've got some heavy machine blocks, as the 2 over there, and heavy machine block, or light machine blocks rather, at the end here. These are just steel fences. And then finally, plain old vanilla hoppers at the top there. So if I click here, I'm going to get myself a crusher. And let me quick fix up the power situation here. Reconnect. There we go. So the crusher is very similar to the thermal expansion pulverizer in that anything you drop in the top is going to get ground up into some more fine version of that, whatever it was. So for example, clear out some inventory here. Let me grab some stuff from this chest here. Now I can go stand at the top here, but if I get myself down in those gears, it will actually crush me up too. So I'm going to be pretty careful to stand well away. Bunch of different things that you can throw in here. So obviously ores are a good candidate. If I toss my ore in there and turn off the redstone signal preventing it from operating, it's going to grind it up into iron grit and send it down that way. If I take some oak wood and toss it in there, it's going to turn it into sawdust. If I take some cobblestone and toss it in there, it's going to turn it into gravel. And if I take some sandstone and toss it in there, it's going to turn it into sand. Now, there's other things you can try, but there's a penalty for experimentation. If you toss in something that it doesn't recognize, like oak planks, you don't get anything out again. It just destroys it. So if you've got a bunch of extra blocks that you don't really need and don't really mind paying a cost in power for getting rid of, you can toss them in your crusher and it will deal with them too. A lot like some of these other machines, you can use a redstone signal to this particular block to prevent the machine from operating. So now I can go stand in the crusher there and it won't hurt me. And it won't crush up anything that gets tossed in there. But here's our outputs from various things. Especially if you're doing railcraft, this is a very convenient way of producing gravel really quickly from cobblestone, which is a lot easier to come by. So there is your crusher. Next up is one of the more exciting of the handheld tools, the Railgun. So the Railgun allows you to shoot iron or steel or various other kinds of rods at a very high velocity. So let's start just by grabbing this Railgun here. And Railguns operate on power. So I've built myself a charging station. And I just right-click the charging station with the object that needs charging. And it's going to toss it in there and charge it. Now, it moves power pretty fast, and this thing is already charged. The green fuzzy signals here tell me that it's ready. It does cycle through a period where it's red first, before it gets there. Okay, so on our little range here, you notice the Railgun has 0, 0 on the very back of it. As I hold down right-click, you can see it charges all the way up and starts making sounds. And you can see there's an iron rod in the chamber. And when I let go of right-click, it fires at my target. And you can even pick them up again, assuming they didn't hit something. So some of the extensions we can add here, we can add additional capacitors so that it gives it more charge and reduces the time it takes to charge. And we can also add a precision scope, which is actually kind of fascinating. So I'll toss those two on there. So here's another couple of shaders, just as some examples here. Here's a blue one, and here's black and red one, which is kind of neat. So take my Railgun here. Now that I've got my zoom, I hold down Shift and then right-click. That tells me I'm fully charged. And now I can use my mouse wheel to change the zoom level. So now I'm zoomed in all the way. And you notice it's not actually super accurate. Now this is about 16 meters away, and I'm still seeing a definite amount of drift, even though I'm not moving my target at all. But it still does pretty darn well. These things can do quite a lot of damage, so very much worth having around a railgun. The only thing, of course, is that your ammunition is pretty darn expensive. Although, unlike the revolver, it doesn't require gunpowder, so you may find that these are a bit easier to deal with because the only fuel or gunpowder is basically just charging the thing up, and that doesn't take a lot of power. So that is your railgun. Next up is the assembly plant. So this is another multi-block structure. You need to click on the inbound conveyor belt, which is that guy right there, to turn it into its multi-block structure. Unfortunately, I need to fix up my power situation again here. Grab one of these, grab one of those, toss that back down. Oops. Standing on the... There we go. Now we've got power. And what this thing does is it's kind of like an automated crafting table. So you right-click and you get these 3 crafting tables, which each of them can be provided with their own recipes. You also have these 3 tanks, which can provide 3 different liquids. So anything where you'd normally use a bucket of whatever as one of the inputs, so making cakes, for example, needs buckets of milk, you can just provide a tank full of milk. And then when you put your buckets here, it will actually use the liquid from the tank instead. So over here, I've got some raw materials that we might use. Let me get myself a... Well, we'll do it this way. So I'm going to take my oak wood, and you notice it didn't use up any of the oak wood. It just takes a little ghost. And it gives me a little ghost of what the output is going to be. I can clear the recipe, of course, by clicking on my little X. But let's say I did that much. Now I'm going to take my oak wood here and just drop it on the conveyor belt, which hopefully doesn't bounce right off. Okay. And now it's gone through, been processed, come out the back end here, and now I've got some oak wood planks on the back end. I can right-click again and say maybe I want to make some sticks. And now I've got sticks and I've got planks. I can go over here and toss in my planks. They go in the machine, they come out the other side as sticks. Now, okay, let me grab some planks here, and we'll add in another recipe where we say, got some sticks, we've got some cobblestone, and now it's going to make a stone axe. So whatever I toss in here is now going to go through each of these recipes. Whoops, did I? Yeah, there we go. Okay, so as I toss in my cobblestone, it's just going to keep it in this inventory down here because there's not enough sticks to fulfill this recipe, right? But as I toss in the oak wood goes in and starts getting processed to planks, which gets processed to sticks, which now gets to use up the cobblestone. So if I toss more cobblestone in there, more oak wood, more planks, more sticks, it's going to use whatever it's got, whether it made it itself or whether I tossed it in here, to fulfill each of these recipes. Now, one silly thing that I overlooked here is each of these stone pickaxes, they don't stack. So they're going to wind up each on their own, which is fortunate that I didn't throw in more materials. But this allows you basically to have a process whereby you walk through 3 recipes at a time. So you can well imagine much more complicated processes where you've got 3 recipes here, maybe you've got another one right next to it that does 3 more recipes, and then maybe some conveyor belts that bring them together and go through a 3rd one that makes the finished product. So you can imagine like making a cake or making pumpkin pies or making even more complex things using these in a nicely automated fashion with your conveyor belts moving from machine to machine. So that is the assembly plant. This is the arc furnace, or at least it will be once I have crafted it. And it's probably the most complicated, or very nearly the most complicated thing in the mod. We've got some steel scaffolding, we've got heavy engineering blocks and light engineering blocks making up the structure. We've got a bunch of these reinforced blast bricks in the middle. And we've actually got steel blocks and steel slabs and a cauldron, which makes up the bottom floor of this, basically. So if I take my hammer and I right-click, I think it's the cauldron, then we get our full-sized block here. So let me straighten out the power here, first of all. and then one by one make my connections back to my batteries here. And this thing can consume a prodigious amount of power, as you might guess, from all of this high voltage stuff here. Um, Depends on exactly what you're doing with it, but this is not a cheap way to do things. But it turns out to be actually kind of valuable. So if, for example, we grab, do I have some ore? Yeah, I've got some iron ingots here, so we'll do that as a demonstration, and some coke dust. The other thing that you need here is these graphite electrodes. These are part of the process, and you can see they fit in these 3 slots up here. Their recipe is you need a blueprint, which is one of the things that you can find from villagers or in treasure chests, and this hop graphite ingot, which is made by smelting the graphite dust, which is made by squeezing coke dust. And coke dust is, you put some coal coke through a crusher and get yourself the coke dust. So it's actually quite a process to set yourself up to even make these things, and you have to find the plan for it. Fortunately, they last for a while. They take damage slowly as you are processing things, so you probably want to keep some extras of these on hand as you're going through making stuff. The recipe looks a little, the interface looks a little complicated, but it's actually not that bad. Over here, you put the raw materials that you want to melt. So I'd put my iron ingots over there, for example. Over here, you put your additives that you want to mix in. So in this case, I'm trying to make steel, so I want to add some coke dust. So I'll put my coke dust over there, put my iron over here, and you notice I can spread out the iron across the entirety of the input panel. So it's going to work on all of these all at once. And you can see it's now getting through, heating up the iron. It's used up some of the integrity of my graphite electrodes. And you can see the animation of it heating everything up. And now it's rapidly kicking out iron after iron after iron. So each iron ingot gets heated up. But I've spread them all out, so I'm producing 12 steel at a time. And every time they melt, they get kicked out the front here. So undoubtedly, much, much more expensive than a regular blast furnace. And you have to provide it with a lot of power. And of course, it makes a lot of slag, which can be just dumped out the back end here. But this allows you to do a lot of really interesting stuff. Not only can you produce things really rapidly, but you also can produce a lot of combinations and alloys that you really can't do in any other way, at least not with immersive engineering. Like many of the larger machines, it has a lever where you can just turn it off at any time. Although I'm going to let it carry on here. And it's using up my coke dust, and so far we're not quite down 2% for doing what basically amounts to a full stack of steel. And compared to our original blast furnace, this is immeasurably faster. Much, much nicer way to go, but very, very expensive, both in terms of power and in terms of raw materials. So that is your arc furnace. Okay, lastly, we have our excavator and our mining core sample drill. And these two things kind of go together. So I keep talking about how, oh, this is very expensive, and this is very expensive, and lots of materials required for this thing or that thing. Well, this is how you get all those materials. All right, so let's plug this thing in and see what we get. So I'm going to connect you to you, and you can see right away it starts spinning its core sample drill. And what it's doing is it's taking a look at this chunk and trying to figure out what ores are present here. Now, I'm in a super flat world, and I know for a fact there are no ores anywhere in this entire world. And so does this thing. What it's really doing is it's just kind of deciding for this chunk whether there are any ores present based upon a table of probabilities that it has internally. And of course, not surprising, no minerals found. But what is really going on is it's deciding whether there are minerals found. If I took this thing and moved it around to different chunks out here in the world, it might eventually decide, hey, this chunk does have minerals in it, even though there aren't any actual ore blocks in the chunk. And this is kind of an important thing because you can't just go around looking for ore blocks and know where the core sample drill is going to find things. They're completely unrelated. And when we finally turn the excavator on, it's the same thing is true for the excavator. The excavator uses the same criteria that the core sample drill does, which has nothing to do with what ore blocks are actually present in the world. It just has its own way of deciding things. So this is the source of truth for this, not what you actually see when you dig around. Okay, so now let's go and whack this thing with our mallet, which I think is this. And now I can right click somewhere. There it is, that block right in the middle there. And that's going to convert this thing into the excavator. Now, this is a pretty complicated piece of machinery, so let's take a look at the instructions here. We've got basically a complex combination of heavy engineering blocks, steel blocks, light engineering blocks, another layer which another mix and match, another layer which has some steel scaffolding in it, which is mix and match. But what that really makes is the housing here, this part around the outside. That does not include the digging wheel itself. So we go to the next page and we see here's the digging wheel, which when converted looks like this, but it's really steel blocks, steel scaffolding, more steel blocks, more steel scaffolding in this big pattern built so that your wheel, that middle block of the wheel, is right in the middle of the light engineering blocks. So you can see over here, the light engineering blocks made, in fact, I'll break that one and put it back down again. I need a light engineering block. Grab you, drop you there. Whoops, I actually needed a heavy engineering block. Anyway, so yeah, you can see this little cross pattern that gets made with light engineering blocks. That's where the center of the wheel has to go in order for everything to line up properly. So that when you right-click this guy here, the wheel also gets converted and made into part of the excavator. So now let's provide this guy with some power and see what he does. Now, unfortunately, we kind of know what he's going to do because our core sample drill already told us that there are no ores in this part of the world. But we can see him starting to operate, where he's digging out, well, nothing, because there's nothing for him to dig out. He might dig out some dirt blocks if there are some in the way, but basically he's going to operate and do pretty much nothing in this world because our core sample drill has told us that there's nothing for him to do. Yeah, we can see underneath here, he's dug out the 3x3 set of dirt blocks at the bottom. But that's kind of all he's going to do because there's no other actual ores according to the core sample for him to dig out. Even if there were really ores in the world, he would still ignore them. But if the core sample had told us that there were real ores here, this would produce them basically out of thin air. And they would just get shot out from this opening at the back and tossed into this chest. And this thing can produce ores for days, stacks upon stacks upon stacks of ores. So as expensive as this thing is to create, and as much power as it requires to run, it requires basically one of these connections. These are three of them is kind of overkill, but it needs about 3072 RF per tick in order to operate. So for all of that, it produces a really tremendous amount of ore with whatever you found. The problem is what happens when the chunk gets exhausted, because this thing will keep going, consuming power, even though there's nothing there. As we can see, there's nothing here, and it's still going, consuming lots and lots of power. So you have to be, one, a little attentive to see when it's starting to get exhausted, and two, once that happens, you basically need to just tear the thing apart and bring your core sample drill somewhere else with some batteries and connectors and keep trying. So you find the ore eventually wherever it is in the world, and then you reconstruct this thing wherever that happens to be. One of the ways that I've found most useful to do this is to take that mining drill with a steel head, so it's got that 3x3 setting, and just drill tunnels underground. Just go straight down, dig all around, and keep moving from chunk to chunk to chunk. Using NEI's chunk boundary tool is convenient because now I can see I've pressed F9 a couple of times, and I can see where the chunk boundaries are. And so obviously this core sample drill is in the same chunk as this excavator. But if I were to move the whole operation over one chunk, then I might get a completely different result and find lots of ores over here where they're not over here. Or I might find a new vein of ores where I had already exhausted one. Okay, that's it for the excavator, and that's it for Immersive Engineering. Huge mod, great attention to detail. I mean, just look at this thing. It's just beautiful. And super nice power transfer systems, and so much attention has gone into making these machines kind of realistic that you don't have a lot of machines that are just 1 meter by 1 meter magic squares. You want to do 3 crafting tables worth of work, you need 3 crafting tables worth of space. If you want to do a big crushing machine, you got to build the whole big crushing machine. So yeah, they're a little more resource intensive than other mods, but they look fantastic. Totally one of my favorite mods, and I highly recommend you get into it. If you like this video, hit like. If you want to know when the next one's coming out, hit subscribe, and I will talk to you later.